Welcome to our summative assessment number 1 in Digital Electronics Lab, and today we are going to apply the concept of digital input and digital output. First, what is digital input? A digital input detects if a voltage is above or below a specific threshold. If the voltage is higher than some value, the computer will detect that the digital input as high, set, or 1. If the voltage is lower than some value, the computer will detect the digital input as low, clear, or 0. For the digital output, a digital output allows you to control a voltage with a computer. If the computer instructs the output to be high, the output will produce a voltage, generally 5 or 3.3 volts. If the computer instructs the output to be low, it is connected to the ground and produces no voltage. For this assessment, we must think of an application of digital input and digital output for the PCB microcontroller utilizing the MCC, the MPLABX IDE. This digital input and output application will be different from the previous experiments and assessments that we did during Digital Electronics 1 lab, wherein we made use of logic gates. The difference for this PCB microcontroller is that PCB microcontrollers or microchips can be programmed using MPLABX IDE. In basic logic gates, for example, if we use a NOT gate, if our digital input is 0, the digital output is 1, and if the digital input is 1, the digital output is 0. In PCB microcontroller programming, we can program the output to execute different commands. So for example, if we set our digital input as 1, not necessarily that the digital output will also be logic 1. We can change it to execute another command. So we have here a sample circuit with 8 output LEDs. With the concept of PCB microcontroller programming, if I set my digital input to 0, the last 4 LEDs will light up and the first 4 LEDs are off. However, if I change my digital input to 1, the first 4 LEDs will light up and the last 4 LEDs will turn off. So let's test it. Through the switch, it commanded the microchip to have a digital input of 0. However, if I change my digital input to 1, the first 4 LEDs turned on and the last 4 LEDs turned off. So for this application, we will be creating 2 basic LED blinking pattern using digital input and output. We can also say that we will be making a Christmas lights-like application. So this is a simplified flowchart for our application. In the flowchart, we declared 2 integer variables, switch and while. And after that, we set the value of while to 0 and input switch. Then we used a while loop wherein inside the while loop there is an if statement. When switch is equal to 1, the output will have a delay ms of 250. And if switch is not equal to 1, the output will have a delay ms of 500. So let's set our switch equal to 1. Enter. As you can see, it output with a delay ms of 250. Now let's test if we set the switch equal to 0. There, it output a delay ms of 500. This flowchart is just the simplified version for the code that we will be using for the microcontroller. This is the flowchart that will be our reference when we will be creating our code in MPLABX IDE. Previously, I showed you a flowchart wherein the program executed the command based on 2 conditional statements. We will also be using that same concept on this flowchart to be a reference when creating the code in MPLAB. Let's test this flowchart. Switch is equal to 1. The output is a pattern of blinking LEDs with a delay ms of 250. So this is the output when switch is not equal to 1 or equal to logic 0. Let's try. Let's set our input switch to 0. Enter. As you can see, it has a different output from the other statement. Here, this is the source code that we will be applying in our main C file project. So in the program, we will be using a while loop. Inside the while loop is a if-else statement, wherein if switch is equal to 0, it will command the microchip, wherein the LED will perform a pattern based on this code. Here in the else statement, if our switch does not equal to 0, to execute this code wherein the LEDs will create a pattern based on this code. Now let's create the code and apply it in our microcontroller. So let's go to MPLABX IDE, then File, New Project, Standalone Project. Next, we will be using a PIC 16F18A75. Next, then XC8 compiler. Next, let's name this Summative 1. Finish. For the MPLAB code configurator, we can click here, the MCC. Let's just save the myconfig file. Since the microchip displayed is different from the microchip that we bought, let's change the package to EDI P40. There. So for this program, we will be using 4 output pins in port A, output of port A0, port A1, port A2, and port A3. For the last 4 LEDs, we will be using the port B0, port B1, port B2, port B3, and for our switch, we will be using port C0 input here at the top. After the pin manager, let's go to system module. Let's set our oscillator select to high frequency internal oscillator, high frequency internal clock 4 MHz, clock divider 4, and low voltage programming enabled. That must be checked. And for the pin module, uncheck the analog in the RA and RB. And for the RC module, check WPU. Let's rename it a switch. Then change the name in the port A and B, LED. After that, let's click generate. Then let's go to project. Go to Summative 1, source file, and the main C file. So in the main C file, we will input our code in the while loop statement. Let's copy the code that we made earlier. The other pattern. Now that the code is complete, let's click build. Now let's connect our PK3 to our microchip. So in the PK3, we have the pin indicator. For the first pin, the M control, we will be connecting it to the first slot in the microchip. For the second pin, VDD, we will connect it on the 11th slot. Then third pin, VSS, on the 12th slot. For the ICSP data, 40th slot. And the ICSP clock on the 39th slot. So in MPLAB IDE, let's go to power. Let's set our voltage level to 3125. Then power target circuit for PK3, check. Operate. Since the PK3 is now connected, let's go to browse. Then let's browse our hex file, Summative 1, this, default, production, Summative 1 hex file. Then program. Programming complete. Now let's test our circuit. So now let's contract the circuit. We already placed the 8 LEDs wherein the negative of the LED is connected to the resistor and is connected to the ground. For the first LED, it will be connected to RA0 or the second slot here. Then second LED, RA1, third slot. Third LED, RA2. Fourth LED, RA3. The last LED will be connected to RB3, 36 slot here. 7th LED will be connected to RB2, 35th slot. The 6th LED will be connected to RB1 or 34th slot. And the 5th LED will be connected to RB0 or the 33rd slot. Let's connect all VDD to the positive terminal. So 11th slot and 32 slot will be connected to the positive terminal. Then VSS, 12th slot, here, ground. And the 31st slot, ground. So I have here a switch with 2 pins. The positive pin of the switch will be connected to the assigned pin switch in the microchip. So RC0 is connected in the 15th slot here. Then the negative pin of the switch to the ground. Then let's connect the positive terminal and negative terminal. Let's also connect another negative here for the LEDs. Now let's test the LEDs. As you can see here, my switch is turned off, therefore the digital input is 0. Then the microchip executes the command, wherein the LED follows the command pattern set in the program. Now let's turn on the switch. So as you can see, the LED output a different code pattern following the code that we set in the MPLAB program.